Ukraine drones wiped out Russian P-18 radar. That was the headline that just exploded across defense circles on January 13th, 2026. And this wasn't just another successful raid. This was a deep, deep strike that really confirms the whole game has changed in modern warfare. Okay. Subscribe to Defense Reports, your go-to source for timely, in-depth military and defense reports. I'm Alex. Join me with Aria in this latest deep dive by Defense Report for a sharp, no-nonsense breakdown of the latest in global defense news, military technology, and strategic developments. And today we're going to cover, well, we're peeling back the layers on an event that, if the analysis holds up, is probably the biggest strategic disruption to air defense we've seen all year.
It's a huge deal, a real paradigm shift.
So our mission today is to get right into the details of that strike from January 12th. We're analyzing how Ukraine's 412th Nemesis Brigade used a wave of strike drones to take out three absolutely vital Russian air defense assets.
And the location is key here.
It's everything. All of them were operating over 100 kilometers behind enemy lines. So for you listening, this is a deep dive into how cheap, mass-produced tech is just paralyzing these massive, expensive military networks.
It's the classic David and Goliath story, but with AI and FPV goggles.
Exactly. So let's start with the targets, because this wasn't just some random hit. The 412th took out a P-18-2 Prima surveillance radar, a Tor surface-to-air missile system, and a 2K-22 Tunguska.
What's so fascinating is how that one attack just neutralized three completely different parts of a defensive system. The P-18, that's the eyes, the long-range early warning.
Right.
But the Tor and the Tunguska, they're the bodyguards. They are built for that close-in, last-ditch defense.
And when we're talking about the Tunguska, I mean, we are talking about a really formidable piece of equipment.
Oh, absolutely. The 2K-22 Tunguska, or as NATO calls it, the SA-19 Griffin. It's designed to be the ultimate protector on the move.
It's tracked. It's mobile.
Exactly. And while the design goes back to the 70s, the modern versions, like the 2K-22M1, were still coming into service not that long ago. And crucially, it's a dual-threat platform. It has missiles, and it has twin 30mm cannons.
So it's designed to throw up a literal wall of metal to shred anything, flying low helicopters, cruise missiles, you name it.
Precisely. And its whole reason for existing is to be that final barrier against threats that have already slipped past everything else.
So hitting 100 kilometers deep, a system designed to stop close-range, fast threats.
It just points to a total strategic failure in how Russia is managing its deep battle space. They were preparing for jets and missiles, kinetic threats. The threat they actually faced was informational, and it was numerous.
Okay, so let's break that down. If the Tunguska is the close-in bodyguard and the Tor is the short-range protector, how in the world do these relatively cheap mid-range drones get that deep?
It feels like it shouldn't be possible.
Right. It seems like a complete mismatch in cost and logic.
And that really is the central paradox of this war. It forces us to talk about the core military transformation we're seeing in Ukraine, a doctrine that, I can tell you, NATO allies are now studying very, very closely.
The drone wall, we've heard that term. Is that just a fancy way of saying they're just throwing more drones at the problem?
No, not at all. It's much more systematic than that. Think of it as an innovative 15-kilometer deep denial zone right at the front line, an A2AD zone.
Anti-access area denial?
Right. They're making the ground immediately behind the front line just too deadly, too observable for the enemy to build up any kind of force.
So it's a robotic buffer zone. But if it's only 15 kilometers deep, how does that help with a strike 100 kilometers away?
Ah, that's the key.
Yeah.
The 15-kilometer wall itself is about casualty reduction. It uses sensors and drones for detection and strikes within seconds, removing your own troops from that initial contact.
Right.
But the system that controls the wall, the whole command and control network, that's what enables the deep strike.
Which sounds like a massive organizational change from, the early days of the war with all the decentralized volunteer drone groups.
It's a total professionalization of drone warfare.
Right.
You have to look at the transformation that started back in 2025 under Robert Brobdy Medjar.
Right.
He spearheaded the shift from those amazing but separate initiatives into a single professional drone army architecture. Standardized FPVs, standardized recon units, even robotic demining, all integrated into every brigade.
And all coordinated by AI.
That's the part that provides the scale. Integration and standardization.
This is where it gets really interesting for me because this January 12th strike, it wasn't just one drone, it was a network. The analysis breaks it down into three distinct strike layers. Let's start with layer one.
Layer one is the immediate response. That's
Yeah.
your FPV drone's first-person view. Think of them as guided munitions with a pilot's eye view, but on demand.
These are the cheap, one-time use tools, the definition of mass at no cost.
Exactly. They're fast, they're nimble, and they're inexpensive enough that losing one just doesn't matter to the bigger picture. Their range is short, 0 to 10 kilometers.
So their advantage is just pure speed.
Immediacy. Only minutes, sometimes even seconds, pass from a sensor detecting a target to that FPV drone hitting it.
And the targets are mostly infantry, light vehicles, maybe enemy drone operators, basically clearing the way.
Correct. They keep the enemy's head down. But they can't deliver the kind of punch you need to take out something like a Tunguska. For that, you need Layer 2.
Which is built for heavy lifting and, maybe more importantly, for night operations.
Now we're talking about the heavy multi-rotor drones. The troops call them the Baba Yaga-class octocopters.
Like the Nemesis, the Vampire.
Those are the ones. They're slower, they're much louder, but they are devastatingly effective. They can carry a huge payload, maybe 15 to 30 kilograms of ordnance.
Perfect for dropping mines or big-shaped charges.
They're the terror of the battlefield at night. Because they have such a high acoustic and thermal signature, they operate almost exclusively in the dark.
So darkness is their cover.
It is. The teams that operate them have these rapid deployment tactics. They'll move to within, say, 3 to 7 kilometers of a target, launch, and then immediately change position to avoid getting hit back. Very surgical.
Okay, so that brings us to the real star of the January 12th strike, Layer 3, the fixed-wing strike drones. This is the echelon that got 100 kilometers deep.
This is the operational game changer. These fixed-wing strike drones are designed to hit targets from 10 kilometers all the way out to 150 kilometers or even more.
So now we're talking about targets that are supposed to be safe from normal artillery, logistics hubs, fuel depots, communication nodes.
And most importantly, the brains of the air defense network.
Yeah.
The radars. Like that P-18-2 they took out.
That feels critical.
It is. The P-18-2 provides the early warning and the targeting data for the Tor and the Tunguska. By taking out that one radar, the fixed-wing drones created a massive cascading effect.
They blinded the network.
Exactly. You blind the network, you paralyze their artillery, and you achieve effects that would normally require risking pilots and jets and suffering huge losses. And they're smart. They can adjust targets in real time, unlike a blind artillery shell.
And if we circle back to that cost issue, destroying a multi-million-dollar Tunguska with a drone that costs, what, maybe $50,000?
That is the asymmetric advantage right there. You're trading cheap, mass-produced systems for slow, expensive, and frankly, irreplaceable strategic assets. It's attrition through efficiency.
But it all feels like it relies on one thing. The drones are only as good as the information you're feeding them. Without a constant stream of data, none of this works.
We absolutely have to stress this. The sensory architecture is the foundation. You could take away the drones, and the fight would continue, just differently. If you take away the sensor network, the entire system collapses. There's no information to act on.
So what does that network actually look like on the ground? What kind of sensors are we talking about?
It's a very sophisticated, multi-layered system. You have acoustic sensors, which are incredible at night. They pick up vibrations from footsteps, engines, even other drone rotors.
So they can classify threats just by their sound signature?
Yep. Then you have seismic sensors buried in the ground, picking by vibrations from vehicles, surprisingly effective. And then you have the more traditional stuff,
The cameras.
your electro-optical or EO modules for high-res images, and your thermal or IR modules for heat signatures. But the real magic is the AI integration. The AI doesn't just show you the data, it analyzes it all at once, the movement, the sound, the heat profile, and it uses that fusion to predict threats.
And that prediction is what shrinks the response time. The AI decides that heat signature matches the sound of a Russian tank, and it cuts the decision cycle from minutes down to seconds.
Exactly. It shrinks what we call the ODI loop: observe, orient, decide, act down to almost nothing. The faster you can act, the less time Russia's big, expensive defense systems have to react.
So what does all this mean for everyone else? This isn't just a Ukrainian tactic anymore, is it? This is setting a new global standard.
It is absolutely dictating the direction of global strategy. Western defense ministries are scrambling to copy this idea of defensive mass without centralized cost. You can see it clear as day in the UK's 2040-40 program.
Right, where they're aiming for only 20% traditional heavy weapons, 40% remote-controlled, and 40% fully autonomous systems. It's a complete rebalance.
And you see it in the U.S. with their ambitious Replicator project to deploy thousands of cheap AI-controlled drones. The core lesson here, especially for NATO countries on the border like Lithuania, is that defense can't rely on slow, static, old-school doctrines anymore. The future is small and networked.
Let's tie this back to the broader war of attrition. Hitting these high-value targets so deep in the rear with cheap systems, it perfectly illustrates that economic asymmetry.
It's economic warfare through technology. The numbers are just brutal. As of January 12th, the estimated Russian personnel losses were around 1,220,000. And get this, they've lost over 104,000 of their own tactical UAVs.
That number of lost drones is just staggering. The skies must be saturated.
They are. And that saturation completely changes the battlefield. The analysis we've seen says the battlefield today is much more World War I and much less Desert Storm.
Meaning no more big, sweeping flanking maneuvers, just a slow, brutal crawl.
Essentially, yes. Neither side can mass enough armor for a rapid breakthrough without taking just suicidal losses. The integrated drone and sensor network will just obliterate the concentration before it can even get going.
Even a big winter offensive would be at risk.
Completely. The supply lines would be under constant attack from these deep strike fixed-wing drones, just like the one that took out the P-18-2 radar. The deep strikes create the conditions that let the front line hold.
So this deep dive really shows that defense is shifting from pure protection, heavy armor, big missile systems to speed, to a networked response driven by AI.
That's the takeaway.
And given the huge economic pressures on Russia, we're seeing reports their railway freight has hit a 16-year low, huge budget holes are opening up. How sustainable is it really for an industrial base that's struggling with Cold War tech to replace systems like the Tunguska or the Tor, especially when they're being taken out so consistently and so cheaply by a more adaptive adversary?
That's a multi-billion-dollar question.
The price of admission to this kind of war is just rising exponentially for the slower force, and that has to be the question keeping military planners awake all over the world. You've been listening to Defense Report by Alex and Aria, where we analyze the latest in military strategy, global defense, and advanced weaponry. Subscribe to Defense Reports, your go-to source for timely, in-depth military and defense reports. We'll catch you next time.